So this is General Physics 2122 or Physics 2122 General Physics 2. Our topic today is Capacitance and Dielectrics. This is under week 4 sa LMS. Our learning objectives are, after this presentation, you should be able to define capacitance. Second, state the function of a capacitor in a circuit. Third, compute the equivalent capacitance of a given series or parallel combination of capacitors. Fourth, describe a process of charging and discharging a capacitor. 5, identify a dielectric material and its effects. Okay, so we have an analogy. A water tower holds water and the capacitor holds charge. The pressure at the base of the water tower depends on the height of the water. And the voltage across a capacitor depends on the amount of charge held by the capacitor. So again, a capacitor is analogous to a water tower. Where sa tower, mayroong water, sa capacitor, charge. So, let us define a capacitor. This is a system that stores energy in the form of electric field. So, as you can see in our diagram, we have a positive metal plate, the left side, and right side, the negative plate. So, this is positive charge, no? So, the direction of electric field is from positive charge to negative. That's why the blue arrows that would represent the direction of electric field is from the left to the right. So, another definition ng capacitor, to make it simpler, no? So, this is a device that stores electric charge. Now, sa second figure, we have electrodes sa upper and electrode up and down, and separated by an insulator. Okay. Now, so that hindi nyo malimutan yung concept ng capacitor, I would like you to imagine a sliced bread. No? Yung sliced bread, dalawang sliced bread, para mas masarap, lagyan ninyo yan ng palaman. So, yung bread, 2 slices of bread are the conductors. Yun ang nag-represent ng positive Q and negative Q. While yung ilagay niyo na palaman, for example, yung sandwich spread, no? Ano man yung mga butter, peanut butter, whatever, yung lagay niyo na palaman, yun ang insulating material. No. So, of course, sa bread at palaman para may panlasa. Pero sa capacitor, ang insulator dito merong mga functions. Bakit ilagay dyan? No? Ang insulating material. So in its simplest form, a capacitor consists of a pair of metal plates. Ito, pair of metal plates separated by air or other insulating material. So ito yung insulating material dito. Or tawagin natin yan ng dielectric material. So ito ang mga examples ng capacitors sa mga circuitry. No? Now, notice na merong polarity ang capacitor. Indicated dito kung saan ang positive leg, positive terminal, negative leg, shorter. Another, mabasa nyo sa body ng capacitor, yung value ng capacitance. Like we have 2,200 microfarad. And we also have 4,700 microfarad capacitor. And what else? Meron diyang 10 volts. So, naka-indicate ang V. So, again, sa body ng capacitor, makikita nyo dyan yung value ng capacitance and value ng V. Now, may mga capacitors din na walang makita kayo na value, but then meron man din capacitor tester to test the value of the capacitor, or capacitance ng capacitor. Kaya ito yung mga sample na mga capacitor sa circuit. Now, ang gamit ng capacitor used in modern electronic circuits to store charge, tuning circuits in radio transmitters and receivers, smooth and regulate the output of electrical power supplies, used in engine ignition system, camera flash, energy backups, and computer if power fails, block surges of charge and energy to protect circuits, serves as memory for ones and zeros of binary code in random access memory. Ang symbol ng capacitor in a diagram, circuit diagram, ito. Gamitin natin ito. Though lahat yan mga symbol, pero mga symbols ng capacitor, pero ito lang gamitin natin. Now, capacitance is the amount of charge. Capacitor is a device. But capacitance is the amount of charge stored per unit volt. Value ng capacitor is capacitance. So we have mathematically C is Q over V, where C is capacitance in farad, Q is charge in coulomb, and V is voltage in volts. So if you are given, if one of the letter symbol here is unknown, like for example, if Q is unknown, then Q is simply C times V, or capacitance times voltage is charge. Or if V is unknown, then charge over capacitance is voltage. Yan. Okay, so another formula for capacitance, using cylindrical, may mga cylindrical type of capacitor. So, kailangan yung area, no? Area, anong area ng plates? In this example, we have a circular plates, no? Dalawa. Tapos, separated by dielectric material in distance D. So, area yan dito. Ito, area na to. So, kailangan, since circular, kailangan natin na radius. That area is pi r squared. So, again, C is equal to Q over V. Kung charge at saka voltage ang given, okay to. But if area and distance ang given, then use this formula. Where we have area for A, D for distance. No? So, take note that capacitance depends on area directly. So, kung ang value ng area is big, that would give us big C. If the distance is inversely proportional to C, no, inversely proportional, that is, pag big ang D, or distance ng separation, that would give us small value of C. So, yan ang relationship ng area, distance, and capacitance. Now, by the way, kung walang insulating material, for example, vacuum, so ito yung formula. But if merong insulating material, take note na wala na itong sub O, because epsilon is equal to epsilon naught, or permittivity of free space, multiplied by dielectric constant na nagdepende sa material. No? Again, kung meron ng dielectric material na na place, no, as between two conducting plates na napalaman doon sa two conducting plates, then we have epsilon. Not sub O ha. So epsilon naught times K is epsilon. Okay. Ito yung mga values ng different materials used as dielectric material doon sa dielectric constants, na different dielectric constants for different materials, insulating materials. So notice na from 1.0006 to 6 to 20. So that depends on what type of metal oxide powders na ilalagay. So yung glass ranges from 3 to 10. So usually kinabigay yung value sa problem. Now, ang unit ng capacitance is farad. So 1 farad is equivalent to 1 coulomb per volt. Now, farad is huge capacitance. Therefore, commonly, ang makita niyo sa capacitor, naka-express in microfarad and in picofarad. So, where microfarad is 10 to negative 6 and pico is 10 to negative 12. Let us solve simple problem to illustrate the concept of capacitance. So a capacitor has a charge of 0.006 coulomb when the potential difference across its plates is 300 volts. So find its capacitance. So balikan nyo yung problem and kailangan nyo i-identify kung ano yung mga given quantities. 0.006 coulomb is charge. Yan dito. 300 volts is potential. And we are going to find for capacitance, question mark. So lagay nyo yan dito. Next thing is to recall, ano yung formula ng capacitance? C therefore is Q over V. Therefore, substitute lang niyo yung mga values, given quantities, no? Q and V. And then next thing is to use your calculator and calculate. So divide 0.006 coulomb, divide 300 volts. That would give us 2 to the power of negative 5 farad. Okay, so what are the factors affecting capacitance? Ano yung makapa-increase, makapa-decrease sa value ng capacitance? First is plate area. Na? So the larger the plate area results in more field flux for a given field force. So less ang capacitance, yes, divide ito. 0.006 divide 300. Do you have a calculator? Sheila, may calculator ka? So, pindutin mo lang yan, okay? Yes, 1, 2, 3, 4. Check po sa calculator, ha? So, 0.006 divided by 300. That is 2 to negative 5. Kulang ka ng isang 0. Tatlong zeros, that is 0.006. And then divided by or slash 300. And equal. So yung makita mo is 2 times 10 to the negative 5 or equivalent to 0.12345. Okay, nakuha? Okay. Thank you, si Ronaldin. Nakuha mo yung answer. Okay, so let us continue. Okay, so again, sa formula na C is equal to epsilon naught because in terms of area, no, we have A over D. So notice na C, depends directly on A. No? So, kung big, again, ang area, that would give us big C. Directly proportional. While yung, so pag small din ang A, small din C, capacitance. So that is how the plate area affects capacitance of a capacitor. Next is the plate spacing. So less capacitance and more capacitance. Sa figure, mas closer ang spacing, mas higher ang capacitance value. Okay, balik tayo sa formula. So C is equal to epsilon naught times area over distance. So makita nyo na C relates distance inversely. So pag big ang distance, that would give us small c. Pag small ang distance, that would give us big C. So, closer spacing results in a greater field force, which results in a greater field flux for any given voltage applied across the plates. So next is dielectric material. What is the effect of dielectric material to the value of capacitance in a capacitor? Okay, so as you notice, na if air is our dielectric between two conductors, the dielectric constant of air is 1.006. While if we place glass between two metal plates, glass ang insulating material natin, then the permittivity of glass is 7.0 or dielectric constant for glass is 7.0. So kung if we consider na constant yung distance of separation, constant ang area, then yung maka-factor lang talaga, maka-affect lang sa capacitance ang type of dielectric material. So mas higher ang dielectric material kung solid ang material compare sa gas. No? So materials with greater permittivity allow for more field flux and thus a greater collecting charge, greater for any given amount of field force. Okay, so ma-illustrate natin yun mamaya. Okay. Next, effect of dielectric material. Ano ang effect ng dielectric material? Functions ng dielectric material. Bakit ilagay doon as palaman? No? So, sa pagkain, sa bread, 2 slices of bread, ilagay yung palaman para mapasarap yung bread. Pero sa capacitor, ano ang function? Ano ang gamit? Bakit lagyan ng insulating material yung dalawang conducting plates? First, it solves the mechanical problem of maintaining two large metal sheets at a very small separation. Mahirap i-separate yung mga metal plates kung walang mga insulating material between. No? Kaya, the first function of a dielectric material is to solve the mechanical problem of maintaining two large metal sheets. Second is to prevent dielectric breakdown. So any dielectric material, when subjected to a sufficiently large electric field, experience dielectric breakdown. What is dielectric breakdown? It's a partial ionization that permits conduction through a material that is supposed to insulate. The third is to increase the capacitance value of a capacitor. So, third function, bakit lagyan ng dielectric material, is to increase the capacitance value. So, capacitance of a capacitor of given dimensions is greater when there is a dielectric material between the plates than in air or in vacuum. So, generally, the when the dielectric material is made of solid, so that would give higher value of capacitance. Okay, so let us illustrate what we have discussed. A parallel plate capacitor has plates 6 square cm and 1.5 mm apart. That's distance. So find its capacitance in air when K is 1.006 and with mica where K is 6 between the plates. So ano yung given sa problem? We are given 6 cm squared. Ano yan? That's distance, square meter. And we also have 1.5 mm, so this is distance. Now, it is very important to convert mm and cm squared to m and m squared. So why? Because in our constant, we have m squared. So dapat naka meters, no? Okay. So let us see conversion ng 6 cm. Kung wala kayong direct conversion factors dyan, 6 cm so we have 6 cm squared. Okay. So, conversion factor natin dito is 1m, 100 cm. Depende sa inyo ha, kung may conversion factors kayo dyan, mas madali. Okay. So, this is equivalent to 6 over, pag mas-square na ito 100, we have 100 times 100, or 6 over 10,000. This time, the unit is m squared. Ma-cancel ito after ma-square dito. So, giving us 6 to the power of 1, 2, 3, 4. 10 to negative 4 m squared. Or this value is equivalent to 0.0006. For 1.5 mm, ang conversion factor is that 1m is 1,000 mm. Okay, so multiply, ma-cancel yan. Giving us 1.5 divided by 1,000 is 1.5 times 10 to the power of negative 3 m. So I hope nakuha ninyo ang conversion of units. Kasi pag hindi kayo makakuha sa conversion of units, mali din yung answer ninyo. Hindi yung kuha yung tama answer. Okay, so next is to recall anong formula ng capacitance. Simply C, since given na yung K, C is epsilon naught so epsilon naught times K, area divided by distance. Okay? So, ito yung formula ng dalawa solution sa A and B. Magkapareho ang value sa epsilon naught, area at saka distance. Pareho ito. So, therefore, magkaiba lang sa value ng K. Ito lang magkaiba. Pareho ang epsilon naught, epsilon naught, area, and distance. So I would like you to get your calculator again and solve the answer in A and B. So it is then expected that the value of capacitance in B, where our dielectric material is K equal to mica, K equal to 6. This is higher capacitance than A. Why? Dahil yung value ng K is 6 compared sa 1.0006. Ayos? Kaya. Okay. Now, in charge ang capacitor, I would like you to visit the capacitor lab para makakita naman din ninyo yung paano mag-charge and mag-discharge ang capacitor. Mas maganda ito pag sa simulation ninyo tingnan. No? So, doon na lang na ninyo yan tingnan. Ano yun? Dalawang zeros. Si Ronaldin. Correct, oy. Correct man. Dalawa. Balik tayo ha. Na, meron pang time. Saan yun ang example? Nasaan ba yun? Ito? Tama man ang given natin. Ito. Yan, dyan. Or 0.00. Dalawang zeros lang. Point 0.006 tapos divided by 300. So, makikita niyo dyan is 0. So, makikita again, ang makita niyo dyan is, so na yan. This is equal to 0. 0.0. And 2. Ito yung makita ninyo dyan sa calculator. Pag hindi naka-scientific notation. Pero pag naka-scientific notation, 2 to the power of negative 5. Nakuha na ba ninyo to? Dalawang zeros lang talaga. 2 zeros na ha, 2, 0, 0.006. Hindi na natin i-alter yung given sa problem. Okay, so hoping na nakuha niyo yan. Ang layo na natin. Okay, saan na ba tayo? Sa charging. Okay, next is to compute or how to find the energy of a charge capacitor. So, to find the energy of a charge capacitor, meron tayong 3 equations for that. So, depende yan kung ano ang given. If charge ang available at saka charge Q and C, then pwede nyo magamit ito. Pwede din C and B, pwede Q and B. Now, the unit of energy is J. That's Joule. Okay, let us see kung makuha natin ito. So, ano ba ang unit? For example, ito. Anong unit ng Q? Q is expressed in coulomb because Q is charge expressed in coulomb. I-multiply natin yan ng volt, where volt, 1 volt is equivalent to joule, 1 joule per coulomb. So when we multiply C or coulomb to joules per coulomb, makancel yung coulomb, that gives us J for unit ng energy or work. So ganun din yung sa derivation ng formula and units sa C and B, Q and C. So to compute for the time constant, by the way, time constant is equal to R times C, where R is resistance in ohms and C capacitance in farad. So, itong time constant na to, this is time of charging and equal to time of discharging a capacitor. Bakit kaya naging unit ng time ang seconds ang unit ng time? No? So, malalaman din ninyo yan pagpatapos tayo sa electricity. Kasi merong equivalent value ang equivalent unit ang ohm. Okay, so a circuit diagram is a graphical or simplified representation of an actual electrical circuit. So sa mga analysis, naka-circuit diagram yan. So sa electronics, we use circuit diagram. Sa mga planning ng mga construction, sa mga bahay, merong blueprint, no? Sa electronics, we have circuit diagram to represent the actual circuit. So this symbol is for a battery or a source, no? Wherein we have the longer plate positive, the shorter negative. Pag i-series natin yung, for example, battery, single battery yan. Pag i-series natin yung battery, connect lang natin plus, minus, and then plus, minus. Naka-series. Now, symbol ng capacitor in a circuit, symbol ng switch, off, no? Kung on, ana siya. Ganyan. And then next, a straight line indicates a wire with negligible resistance. So kung anong mag-connect sa one device to another, that would be represented by a straight line. No? So, or a line. That's wire with negligible resistance. Okay, so capacitors in combination. So sometimes in order to obtain needed values of capacitors are combined in either series or parallel, or series parallel, parallel series. Now, anong importance of having a knowledge how to connect capacitors or how to combine capacitors? So isang advantage, for example, kailangan niyo ng 500 microfarad. And then pagpunta niyo doon sa electrical supplies, walang available na 500 microfarad. You want 500 microfarad para i-replace doon sa circuit, no? But then walang available na supply na exact 500 microfarad. But then merong mga other values ng mga capacitors. Like halimbawa, kung merong 1,000 microfarad, paano niyo i-connect yung 1,000 microfarad na magiging 500 microfarad? No? So, in this case, kung for example, dalawang 1,000 microfarad, ano yan i-connect? So, pwede niyo natin i-connect ito na mag-exact sa 500 microfarad. So, let us define muna ano yung mga constants and ang formula sa series at parallel combination ng capacitors. Okay, so let us continue. We are now in the capacitors connected in series. Okay, now, as I have said kanina na merong polarity ang capacitance. So, naka-indicated doon yung plus and minus legs. Wala bang audio? Okay. Okay. Sige. Again, capacitors connected in series. Now, notice na yung sample capacitor kanina, electrolytic capacitor, meron positive at saka negative terminal or legs. No? Now, in series connection, we have to do is to connect plus, minus with plus, and minus with plus. So, plus, minus, plus, minus. Ganun yung connection ng series. Now, since single path lang ang dadaanan ng charge, single path lang yung daanan ng charge, then Q is constant. Di ba yung factor sa C? C is Q over V. Factor ng C is Q and V. No? So, in the series connection of capacitors, Q is constant. Again, kasi isang path lang ang madaanan ng charge. Therefore, whatever charge entering would be same charge entering and leaving ng capacitor 1, capacitor 2, and capacitor 1. So again, single path ang flow ng path na charge. So to find for the C total or C, may mga nakasulat na formula na CEQ, or this is capacitance equivalent or equivalent capacitance. Pareho din yan sa CT. No? So you add the reciprocals of the capacitance of the capacitors, and then kunin pa ninyo yung reciprocal. So that is how to find for CT if capacitor is connected in series. And to find the total voltage, then V1, every capacitor may C, may V, may Q. No? So V total is V1 plus V2 kung dalawang capacitors lang. Okay, so wag niyo kalimutan ang formula to find V, to find Q, no? Example, find the total capacitance for 3 capacitors connected in series. So given their individual capacitances, 1 microfarad, 5 microfarad, and 8 microfarad. Wala na ito. Okay, so first thing is to draw a diagram. So tatlong capacitors at saka i-label ninyo C1, C2, C3. And then recall the formula for series capacitors. Formula ito. So next thing is to substitute. So 1 over C1 plus 1 over C2 plus 1 over C3. Reciprocal. So kung merong calculator, paki-check. Sige daw, paki-check daw sa calculator. Wala problema? Kuha ninyo ang value. Sino na nakakuha sa value na 7.55 to negative 7? So similar yan sa example natin kanina. What if we have dalawang 1,000 microfarad capacitors? Tapos i-combine natin yan. Ano ang equivalent capacitance? 2, 3, Microfarad. Sige. Use your calculator. Thank you for reminding. May noise kasi dito. Okay, so capacitors connected in parallel. So take note na we combine two parallel legs na connected sa common point. Plus terminal and plus terminal. Negative terminal with negative terminal connected as one. That's why parallel yan. Or kung meron tayong source, dito yung source. Okay. So, sa capacitors in parallel, ano ang constant? So, kung merong source dito, so take note na yung dalawang negative terminals sa dalawang capacitors connected to a single source. Yung positive naman connected to the source. So that the constant in capacitors connected in parallel is the voltage. This is the constant. So, if this is our VT, therefore, V1 natin ito equal sa VT. V2 natin ito equal to VT. And to compute for the equivalent capacitance, or CEQ, or C total, i-add lang ninyo C1 plus C2. Or kahit how many capacitors pa, no? I-add lang ninyo basta connected ito in parallel. And to solve for Q total, simply add Q1, Q2, and Qn. Huwag niyo kalimutan yung formula to find Q. Okay, example. Find the total capacitance for the three capacitors connected in parallel. This time, same values of capacitors in the previous example, but then the connection is from series, this time parallel, no? Okay. So to find C total, because we are asked only to find the total capacitance, then C total is simply by following the formula. 1 microfarad plus 5 microfarad plus 8 microfarad is 14 microfarad. So kung ang capacitors connected in parallel, the C total is large, no? It gives a higher value of capacitance compared when connected in series. If you want to increase the capacitance of the capacitors, i-connect lang niyo yun ng series. If you want to reduce the value of the capacitors, capacitance ng capacitor, i-connect niyo in series. Okay, so lesson summary. A capacitor is a system or a device that stores energy in the form of an electric field. Basically, in the simplest form, it consists of a pair of metal plates separated by a dielectric material or an insulating material. Symbol ng capacitor, yan, sa circuit. And we have another formula. So C is equal to Q over V is equal to epsilon times area over distance. So kung charge ang given at saka voltage, pwede nyo ito gamitin. But if area at saka distance, ito din gamitin ninyo. Equivalent na. The unit of capacitance is farad, and 1 farad is equivalent to 1 coulomb per volt. So usually, ang capacitance value expressed in terms of microfarad and picofarad. So micro is 10 to negative 6, pico is 10 to negative 12. Now, factors that would affect capacitance, first is the plate area. So larger plate area results in more field flux for a given field force. Directly proportional yung area doon sa capacitance ng capacitor. Plate spacing is, ito yung distance, na? So distance is inversely proportional to capacitance. Therefore, closer spacing results in greater field force, which results in greater field flux for any given voltage applied across the plates. Dielectric material, so materials with greater permittivity allow for more field flux, and thus a greater collected charge for any given amount of field force. So, generally, pag ang dielectric material made of solid or mga solid materials, then higher ang capacitance value compared in air or in vacuum and even in liquid. Okay, so next, what are the effect of dielectric material? What are the functions? Bakit ilagay ang dielectric material between two conducting metal plates? So first is to solve the mechanical problem of maintaining two large metal shields at a given small separation without actual contact. Second, any dielectric material, when subjected to a sufficiently large electric field, experience breakdown or dielectric breakdown. So dielectric breakdown is a partial ionization that permits conduction through a material that is supposed to insulate, simply to prevent dielectric breakdown. Third is to increase the capacitance value of the capacitor. So third function ng dielectric material, anong gamit ng dielectric material, is to increase the capacitance value. So capacitors in combination, capacitors connected in series, the constant is charge. This is how to find the equivalent capacitance and the total voltage. Capacitors connected in parallel, this is how to find for the capacitance, total capacitance, and voltage is constant. And to find total charge is the total of the charges ng capacitors. Now, if you want to increase, if you want a large value or bigger value, or if you want to increase the capacitance of a capacitor, you connect it in parallel. If you want to decrease, then you connect it in series. Okay, so that's all for today.